Alright, I can't really tell what this is saying, so I'm just going to make some assumptions. I'm going to copy it down. So here we have a limit as x approaches infinity. We have tricks to do for limits at infinity, where x is approaching infinity. And one of the tricks is to, well, first of all, we should plug in infinity and see what we get. I think in the top we get infinity plus this would be infinity minus infinity. We already have infinity minus infinity. That's an indeterminate form. And then in the bottom we also have infinity minus infinity because of that part and that part. So we have an indeterminate form. We got to do some tricks. That being said, the trick for limits at infinity is this. So the first trick is if you have a ratio of polynomials that are the same degree. So let's take a look at this. Here we have degree 5 and degree 5 polynomials. So remember, the degree of a polynomial is just the same as the degree of the highest power. So if you have a ratio of polynomials that are the same degree, the limit is the ratio. The limit is equal to the ratio of their lead coefficients. So what I mean by the lead coefficients is just the coefficients that are in front of the highest powers. So this one would end up being 3 over negative 6, which is negative 1/2. So that'll be our answer. That's like a shortcut. If this doesn't work, then we can use a different trick, which is to factor out the highest power exponent, or the highest power of x in the denominator, and factor out the same power of x in the numerator. And actually, that's how I'm going to show you why it's negative 1/2, and I'm going to be doing that by showing you the second trick. So tricks for limit at infinity, as x approaches infinity. You know what? I'm going to change this. I saw this. This is what Sales teaches, so I'm going to steal it. Factor out the highest power of x. It's the same thing. It's actually doing the same thing, but maybe this is a little bit more simple. Multiply the top and bottom by 1 over the highest power of x. So here we have multiply the top and bottom by 1 over the highest power of x from the denominator. So we're multiplying it to the top and bottom. This is kind of confusing the way I've worded this, but we're multiplying it to the top and bottom, so we're actually multiplying by 1. And what are we multiplying by? We're multiplying by 1 over the highest power of x from the denominator. So let's take a look back at our problem. We're doing this. I'm showing you, we're already done. I know the answer is going to be negative 1/2. But I'm showing you why the shortcut works, because it works with the second part. This is not always going to work out, so we're going to probably use this a lot more. But if you have the same degree in the top and bottom, then this is what you can do. Or the shortcut is what you can do. Just be careful. This is only for limits as x approaches negative and positive infinity. I guarantee you that some people are going to get this confused. So please, please, please remember that there's a condition that goes along with this shortcut. So be careful. All right. Let's see what is the highest power of x from the denominator. That's x to the 5th. So what I'm going to do is I'll rewrite this stuff in green. 3x to the 5th plus 2x squared minus x plus 9 divided by 7 plus x squared minus 6x to the 5th. And now I'm going to multiply the top and bottom by 1 over x to the 5th, because that's the highest power of x, and I'm doing 1 over that. And if I do it in the top and bottom, then really I'm multiplying by just 1 here, so I don't really change anything. And let's see what happens. So I would distribute all of this in. So I would get just 3 plus this times this. That would be x to the 5th on the bottom, so that becomes 2x to the 3rd, right? And then minus, 1 over x to the 4th plus 9 over x to the 5th divided by 7 over x to the 5th. What is this? 1 over x cubed. I'm just distributing here. And then minus 6, right? And now we can reevaluate our limit. Limit as x approaches infinity. Here's the thing. If we're remembering our one of our fundamental limits, recall that the limit as x approaches infinity of 1 over x equals 0, because the denominator is getting really, really large and the numerator is staying relatively the same. So we're going to take a limit of each of our pieces here. This one's going to go to 0. This one's going to go to 0, going to go to 0 because of this property right here. And this is actually a plus or minus infinity. That's one of our fundamental limits while x approaches infinity. So this goes to 0, this goes to 0. So it's quite nice. Here to 0, to 0, to 0, to 0, to 0. And what are we left with? We're left with 3 and a negative 6, which is 3 over negative 6, which is just the same thing as negative 1/2. So there we go. Those are the tricks, and I'm gonna leave now. Goodbye.